Examples on finding components of vector. First example is, let us say there is a block on which a force of 40 Newton is acting as shown by the arrow. Let us say these are the x and y axis and the force makes an angle 30 degree with the x axis. The x component of the force Fx can be found by dropping a perpendicular from the head of force F to the x-axis. The length from the tail of vector F to the foot of perpendicular will be equal to the component of force along the x direction, and this will be equal to 40 cos 30 degree. Similarly, the y component of the force Fy can be found by dropping a perpendicular from the head of the vector along the y-axis. The component will be equal to the length of the line from the tail of vector to the foot of the perpendicular, and this will be equal to 40 cos 60 degree. Thus we find the x component of the vector and find the y component of the vector. In the next example, example number 2, suppose a particle is thrown in the air at a certain angle. The path followed by the particle is parabolic and the motion is called as projectile motion. This is the x-axis and this is the y-axis. The initial velocity of the particle when it was thrown can be represented by the u vector. The initial velocity makes an angle alpha with the x-axis, and after some time the velocity of the particle while it is in air changes. The new velocity of the particle is v vector, and this vector makes an angle beta with the x-axis. Alpha is not equal to beta because the angle the velocity makes with the x-axis keeps on changing. The component of the initial velocity u can be found by dropping a perpendicular from the head of u vector along the x-axis. The component along the x-axis will be the length from the tail of u to the foot of perpendicular, and this will be equal to u cos alpha. Similarly, the component along the y-axis can be found by dropping a perpendicular from the head of u to the y-axis, and the component along the y-axis will be equal to the length of the line from the tail of a to the foot of perpendicular. So this will be u sin alpha. The initial velocity of the particle in terms of x and y components can therefore be written as u vector is equal to u cos alpha I cap plus u sin alpha j cap, where u cos alpha is the x component and u sin alpha is the y component. Similarly, to find the components of v vector along the x direction, we drop a perpendicular from the head of v to the x-axis, and the length from the tail of v to the foot of perpendicular will be the component of v along the x-axis. This will be equal to v cos beta. Similarly, to find the component of vector v along the y direction, we drop a perpendicular from the head of v along the y-axis. The component along the y direction will be equal to the length from the tail of v to the foot of perpendicular along the y-axis. This length will be equal to v sin beta. Thus, in the rectangular form, we can write v vector is equal to v cos beta I cap plus v sin beta j cap, where v cos beta is the x component of the vector v and v sin beta is the y component of the vector v. Finally, let us look at this example. Let us say there is an inclined plane. The inclined plane makes an angle alpha from the horizontal, and on the inclined plane there is a box of mass m kept. We know that the earth will attract the block by a force of mg. To find the component of the vector mg along a direction which is parallel to the plane of which, we will drop a perpendicular from the head of mg along the direction component of the vector will be equal to mg sine alpha. Similarly, if we want to find the component of the vector along a direction which is perpendicular to the plane of the wedge, we will drop a perpendicular from the head of the vector mg to that direction. This angle will also be equal to alpha. Therefore, the length from the tail of the vector to the foot of perpendicular will be equal to mg cos alpha. Thus, mg sine alpha will be the component along the direction of plane and mg cos alpha will be the component perpendicular to the direction of plane.